topic 9-3. This can be referenced with our Holt textbook, Chapter 9, Section 1, on page 590 through 591. We're dealing with area and perimeter, this time of triangles. You're going to need, with your topic pages, there was a page to cut out 2 triangles. So after we've done some labeling, we're going to end up using these in a second. Recall that a triangle is a polygon with 3 sides. The base is any side of a triangle, so you can really choose any base, and notice we put base subscript 1, base subscript 2, or this could actually be the base subscript 3. Subscripts are used to show which base and height match up. So if you're using this as the base, the height would be this one here. And it's also called an altitude. The altitude is a perpendicular segment from the vertex of the opposite, the chosen base. So notice if I use this base for base 2, then the base height would be this one here. And if I use this one for the base, then this is the height. So corresponding subscripts go with the base and height that would match up. So take these pieces of paper with the scalene triangles, scaling being all different side measurements, and fold it along the dotted line. And it says cut through both thicknesses to obtain 2 congruent triangles. We're not going to actually cut ours. If you fold along this dotted line, you've got 2 triangles. Notice what happens. Your parallelogram of one and the parallelogram of the other form 2 triangles. And it says cut through both thicknesses to obtain 2 congruent triangles. Well, if you'll show the 2 congruent triangles, that's a triangle and this a triangle. That makes up your parallelogram. You've formed a parallelogram by putting them together. How would you calculate the area of this polygon? Well, we've already gone over the area of a parallelogram is base times height. So the area of a parallelogram in relation to a triangle, how do they compare? Well, if you know that it takes 2 of these to make up the parallelogram, the triangle is half of it. It's just one of them. So you can go ahead and tape your examples, these 2, on your topic 9.3's first page. Okay, another theorem to note. The area of a triangle theorem states that the area of a triangle is half the product of the base and its corresponding height. So area equals half of base times height can either be written this way or 1/2 base times height. So a lot of times I'll use this way. Dividing by 2 is the same thing as multiplying by 1/2. Okay, to find the perimeter of a triangle, simply add all of the sides. So your perimeter would just be adding up, walking around the triangle, looking at all the different side lengths. So for this one, the area you would find by multiplying 19 times 26 and dividing by 2. So the area is 247. To find the third side, we need to be able to find the perimeter of this triangle. You're going to use Pythagorean Theorem. You know the 2 side lengths, squaring them, adding them together, and taking the square root would give you your third side. And since this square root does not simplify, you're going to add the 26 and 19 together along with that square root. You can only add the whole numbers and leave the radical like it is. So go ahead and just label what your base measurement was, your height measurement, your area, and your perimeter. Okay, for this one you're going to have to fill in some values. If they give you this value of the entire length of this base as being 13, then this smaller base of just this triangle here would be 10, because they've given you this is 3, 13 minus 3 is 10. So for the area, you're just taking the 13 times the 4 and dividing it by 2. That's going to give you the area of this triangle, which would be 26 units. For finding perimeter, we needed this side length. Well, you can't use Pythagorean theorem with this entire triangle because this was not stated as a right angle. So we do have a right angle here, so here is where we can use our Pythagorean theorem. This hypotenuse makes up the legs of the triangle 4, 10. Squaring both sides with Pythagorean theorem, setting them equal to this unknown side, you're going to get 116. So taking the square root of both sides, you're going to factor simplified of the square root of 116 is 4 times 29. Well, 4 square root of 4, remember, is just 2. That's where this 2 came from. 2 square roots of 9. Again, when you're adding up the sides, you're going to add the 5, the 13, and the 2 square roots of 29. You cannot combine. You can combine these two for 18, but this has to stay separate. Just like in this example, you had to keep your whole number and your radical separate. In example 3, because this is an isosceles triangle, there is a theorem that we can prove that these will break into 2 equal triangles, so that would also be a 2. So the base length here is 4, and the height of this is, through Pythagorean theorem again, 4 square roots of 2. So 4 square roots of 2 times 4 divided by 2 is going to give you 8 square roots of 2. Walk through each of these steps slowly and making sure you understand how that came about. For perimeter, you're just going to add up all the sides. We've got a 6, a 6, and a 4, which is 16. Alright, moving on. For the area of a 45, 45, 90 triangle, the reason I know it is that this side and this side are the same. Well, if this side and this side are the same and this is perpendicular, any diagonal I draw would create a 45, 45, 90. Try to get in the habit of seeing that this would actually be the diagonal of a square. Okay, the only thing given to you was a 7, so you're setting 7 equal to x square root of 2. That's the value of this diagonal line. When multiplying by a power of 1, which is the square root of 2, you rationalize the denominator, giving this a positive 2. This cancels out, and 7 times square root of 2 is 7 square roots of 2. Divide 7 and 2, you get 3.5, 3.5 square roots of 2. Keeping the radicals separate from that can be derived. So this is the value of x. Well, to get an area, you're multiplying 2 of these and then dividing by 2. Remember again, base times height divided by 2 gets the area of a triangle. So this one's going to end up being a whole number. You can use a calculator, or you can realize that square root of 2 times square root of 2 is square root of 4, which is 2, so that's why this is shown to be canceled out. So you're basically just multiplying 3.5 times 3.5. Perimeter again is taking the 2 sides and then the hypotenuse and adding them together. Notice again that I can add this back to 7 square roots of 2. 2 common radicals stay a common radical, but don't add it with the constant that you have in 7. It can't be added to that. A little bit more review of radicals. Okay, for perimeter of this one, well, first let's note that this is an equilateral triangle. I don't know if you can see it, but the tick mark is here, here, and here. So if 8 was given to me, I know that all the sides are 8. Therefore, adding the sides together give me the perimeter. In order to find the area, I need to know this height measurement. Well, in an equilateral triangle, each one of these is 60. 60, this would be 60, and this is 60. You've created, in this right here, a 30, 60, 90. If you want to draw it kind of out by itself so that it doesn't look all jumbled, you can. If this is my value of 8 being total across, this would be a 4. This distance from here to here is going to be a 4. On a 30, 60, 90, this value is x square roots of 3, that side length, and this hypotenuse is 2 of this length, which of course is equal to 8. 2 times 4 is 8. So now that we've discovered that x is equal to 4, then this height measurement is 4 square roots of 3. So, multiplying, you go back to your formula, your base is 8 times 4 square roots of 3 divided by 2. They reduced, this becomes 4. 4 times 4 square roots of 3 is 16 square roots of 3. Again, using more radical rules. Okay, on number 6, you're going to need to fill in a 6 for this measurement from here to here, because we really can't assume that it is half and half. This appears to be 2 equal triangles, but we cannot assume that they are such. So if we know that this is a 6 and this is a 3, then you can multiply, well, knowing that this is also 6 means that this full measurement is 12. 12 times 3 divided by 2 gets you the area of this right here, so that's going to be 18, let's see, 12 times 3 is 18, I'm sorry, not 18, 36, 36 divided by 2 is 18. This is a composite figure, so we just got the area of the triangle, now you're getting the area of the rectangle, which would be 12 times 5. You're adding these two together to get the total composite figure's area. Last one. A triangle with an area of 46 has a base of 4. What would its height be? Well, if you've already been given the area, you're just going to fill it in. The base has been given to you as a 4, so you're just going to fill it in. What you're left with is dividing it by 2. If I'll show this with a different color, we can see this. I'll put the different color here. If you're multiplied by 2 on both sides, the reason for that is to get rid of the 2 that's in the denominator. Then you just have the 4 times the height is equal to, this is 92, and then divide by 4. Let me walk through this with you in more detail if you need to go over that together. So this would be 23 units for the height. And that concludes 9-3.